Hi everybody, so I wanted to make a little video about checking your work with the calculator for half-angle formulas. I know it's really important to have that validation when you're doing your work to know that what you're putting in is correct. And in the last video, I did give you a quick note about calculators that said we can't really trust them to give us the correct answer because it can't tell you what quadrant we're in. But we can hack this by thinking through the quadrants and making some adjustments to our calculations. I'm going to use the problem we did where we found the cosine of u over 2, given that cosine of u was 15.81 and u is in quadrant 2, where we went through the steps to find out that cosine of u over 2 is 0.03, but this time I'm going to use Desmos to come up with this calculation. The first thing we want to do is use this cosecant of u is 15.81 and u is in quadrant 2 to start us off. I'm going to go to my settings and I'm going to switch to degrees because I think we do better thinking through degrees and what that looks like as far as quadrants are concerned. I'm going to type in the cosecant inverse of 15.81. And notice it tells me 3.62. To help us picture that, I put in a line segment in quadrant 1 to show it's really small. But this is our big problem. Our angle is in quadrant 1 and we're supposed to be in quadrant 2. What this tells me is the 3.62 angle we have is a reference angle. It's not our true angle. So we need to think about what angle in quadrant 2 has a reference angle of 3.62. To find our angle, we could take 180 and subtract 3.62644227396. This tells us our actual angle is 176.373557726. That moves our angle into quadrant 2, which is where we're supposed to be. Now that we have the correct angle, we can find the cosine of u over 2. I'll type in cosine of 176.373557726 and then divide by 2, and I get a value of 0.0316413967749, which we had rounded to 0.03 when we did the problem originally. This shows we can use calculators to help us find our half-angle values. We just need to make sure we make a few adjustments to our calculation and put our angle in the correct quadrant.